What is the structure of artificial neural networks? Have you ever wondered how machines learn and make decisions? The answer lies in the fascinating world of artificial neural networks. These systems are inspired by the way our brains work, using layers of interconnected units called neurons to process information. Let's break down how these networks are structured and how they function. The first layer in an artificial neural network is the input layer. This layer is where the network receives raw data from the outside world. Each neuron in this layer represents a specific feature of the input data. For example, in image processing, each neuron might correspond to a pixel value of an image. Next, we have the hidden layers. These layers sit between the input and output layers and can vary in number. Neurons in hidden layers perform computations to extract and transform features. They do this through weighted connections and activation functions. The number of hidden layers and their size can greatly affect how well the network learns complex patterns. Each neuron in a hidden layer takes inputs from the previous layer, applies weights to them, sums the results, and then uses an activation function to introduce nonlinearity. This allows the network to model complex relationships in the data. Finally, we reach the output layer. This is the last layer of the network and is responsible for producing predictions or classifications. The number of neurons in this layer corresponds to the number of outputs the network is designed to generate. For instance, in a digit recognition task, there would be 10 output neurons representing the digits 0 through 9. Each neuron in these layers is connected to adjacent neurons through weighted connections. These weights determine how much influence one neuron's output has on another. During the training process, the network adjusts these weights to reduce errors in its predictions. Inside each neuron, there are key components. Inputs are the data received from the previous layer. Weights are scalars that scale these input values, showing how important each input is. There is also a bias, which is an additional parameter added to the weighted sum to adjust the activation function. The activation function itself is a mathematical function that processes the weighted sum plus bias, introducing nonlinearity. Common activation functions include rectified linear unit, sigmoid, and hyperbolic tangent. The network operates through two main processes. The first is feedforward, where data flows from the input layer through hidden layers to the output layer, generating a prediction. The second is backpropagation, where the network calculates the error between its prediction and the actual output. It then sends this error backward to update the weights and biases, improving accuracy. Artificial neural networks can be structured in various ways. For example, feedforward networks have connections that move in one direction, while recurrent networks can loop connections back, allowing the network to remember previous inputs. In the realm of artificial intelligence applications such as ChatGPT, DALL, and Midjourney, neural networks are foundational. They help these models understand language, generate images, and improve productivity through plugins. These systems relying on deep neural networks with many hidden layers, which enable them to capture complex patterns in text and images. Understanding the structure of artificial neural networks reveals how these systems learn from data, make decisions, and create outputs. It also raises important questions about ethics, transparency, and responsible use in technology.